And thanks Upcloud for having us. It's always very good to have nice spaces like this to meet and talk about cloud-native technology. So we have 4 talks planned today. One on OpenTofu. There is one about how about AI native and cloud native, what means what, and where the world goes with all of this AI craze, let's say. Then a bit of IoT and edge talk, and then we will have another AI talk about LLMs. So it's a very diverse set of topics, and I think all of the talks are very relevant. So it is a very good content. All Meetup is part of the Cloud Native Nordics, which is basically a community of meetups around the Nordics. We have meetups not only in Finland, but also Norway, Denmark, Sweden, and Iceland. And all of these meetups are working together. And we are very proud to be a member of the Cloud Native Nordics meetup community. The Helsinki meetup community is relatively big, like we have around 2,000 members, and we are growing every month. I don't know who is the first comer to this meetup. Raise your hands. All right, welcome, and I hope that you will be a returning meetup participant. We are following the CNCF and Linux Foundation Code of Conduct, which is basically means that be nice to each other and share the love. If you would like to go into the details, I can send you the link. Just come and find us. We are always looking for speakers, and we are always looking for sponsors. Especially, we are now looking for a sponsor for the September meetup. So if your company would like to sponsor a meetup and you have the possibility to do it in September, we would be very happy to start a discussion. If you would like to talk to us, just come to any of the organizers. Please, organizers, raise your hands. So just find us and talk to us if you would like to speak, if you would like to sponsor a meetup in the future. We have community tools in Slack, so you can follow us on Slack. You can follow us in LinkedIn. You can follow us in YouTube. We are streaming the meetup, so you can find all the presentations in YouTube. So thanks for that. Yeah, you can find in all of these. And the third leg of the CNCF governance is the end user community. So the the end users who are using these projects, not necessarily building
here is this one. You are free to build on it. So if you want to, well, even embed Terraform or Vagrant or whatever in your product, you are free to do so. Okay? And the change to business source license is giving the licensor the opportunity to, simply speaking, say that you can't use my product. Why? Because I don't like you. In general, this is the real, real problem with this license. And this license is somehow, I would say, foggy, because I call it parameterized. So you have usage restrictions. You have also the possibility to change, to say when the license will be changed from BSL to MPL, for example after 5 years or something like that, and what will be the license after this change. So everything here is in the hands of the licensor. Still, it's maybe not that bad, right? When you start with that, you know what you are, signing for, and so on and so on and so on. Changing really open license to kind of closed, because you can say to someone that you can't use my product, and this really would happen, was like a big storm in the community. So probably those of you who observed what was happening there was a lot of, I'm sorry to say that shitstorm, right? Was a lot of discussions and so on and so on and so on. So some people even say that it is very good that Hashi changed this license, because those parasites who are using this to build their product will be finally, kicked off. Well, yeah. It was said about Spacey, Zero, Scalar, Pulumi, and other, vendors, tools, and so on. But also about, for example, GitHub Actions, about GitLab, about CircleCI, and so on and so on and so on. Because this license change was one of the reasons why they changed it, was against tools called tacos. How many of you are familiar with tacos? I mean, not food, but the tool called tacos. So it's Terraform automation tools, right? Generally, right? On 10th of January 2024. And funny story is about this. Maybe some of you who followed very, very carefully what went on Twitter. I'm sorry, for me it's still Twitter, not X. Very quickly after the fork, Mr. Stadil, who is, if I remember correctly, owner of Scalar, posted something new, what was implemented in OpenTofu. Do you know what? State encryption. Something what was asked by the community to Terraform. But how old was Terraform at that time? 10 years? Something like that, right? So the pull request even with state encryption to Terraform was 10 years old. We implemented this. And then we just, hey, guys, no, let's make this stable, then we will create features. So we deleted those messages, deleted the code, and so on, and so on, and so on. That's why state encryption was announced in 1.7 or 1.8, I don't remember, 1.7 I did. So this was the first stable release, and surprise, really a lot of companies, not like just 2 people startups, but proper established companies, came to us and said, hey, help us to migrate everything to OpenTofu now, because we hate what happened. It was like really, really surprising for us. That's why some of them, like for example, Spaceit, started to think about something what was called at the time professional services. So how to help others to migrate to OpenTofu. And of course, if you remember how much Terraform changed from that day, in fact, it is good for the community, because right now Terraform has a proper competitor, very close competitor. So to stay where they are, because just to be clear, Terraform is still a very good tool. They had to do something. So that's why we have 1.14 right now, or something like that. So on 19th of January, we sent the application to CNCF. So yeah, it was my input into that. And finally, on 23rd of April this year, we as OpenTofu entered CNCF. So it's quite new. It wasn't announced very loudly, I will say, but still, all teams behind that are very, very happy. And you know what was interesting? When the OpenTofu was created, there was a lot of questions. Okay, so you parasites, you created something to still do your business, right? And money. How we can trust that you will maintain OpenTofu? First of all, joining the foundation. So now, in the reality, we are not the owners, or those companies are not the owners of it. In fact, in this case, CNCF is. They manage how it works, maybe not how it works, but where it will go. And second thing, it was claimed by a couple of companies to fully focus couple of developers, for example. For example, Spaceit and M0 said we will hire 5 people just for working on it for 5 years. So quite huge commitment, I would say. All right. So again, was OpenTofu created because those parasites were competing with Terraform? No, those parasites were competing with Terraform Cloud and Terraform Enterprise, right? So this is like this small difference here. And what we have inside, the structure, everything is very close, because we have the binary, right, the core of Tofu or Terraform, because OpenTofu binary is called Tofu. The advancement over Terraform, count the number of letters, what you can type faster. We have HCL, which is the language we use to create our templates. From the second side, we have providers who are like using, let's call API to connect to the event to the our target, like AWS or Azure or whatever else, and also like have this protocol between the binary and the providers to, let's simply say, push this template to the provider. And then we, of course, we have registry, where you can store and download all those providers, then modules, and so on, and so on, and so on. And with the registry, we had also a nice story, because Tofu on the beginning was like 100% compatible with Terraform, right? And we used the HashiCorp registry. And after one night, we wake up and we see that in the license for registry, there is a new entry saying only HashiCorp tools can use this registry. Nice. Of course, we still could use repositories, right? We still could download the providers from the repositories, normally from the Git, but we couldn't use registry.hashicorp.io, right? So what we've done, the same what we could do and we were the best in. We forked the registry. Of course, finally, we didn't use this. We started to think about something else. We created at the time like a temporary registry. Now, as I know, they had the proper registry, proper, GUI and so on and so on and so on. And generally, what is really funny, after we implemented the registry and we counted number of providers, we realized that we have more providers than HashiCorp in the registry. Because we came out with the idea to have this as really open source. So if you provide your registry, your GitHub repository for your provider in the proper schema, it will be like uploaded to the registry automatically. And Hashi had some control over it, so some providers were not there, right? It has its pros, it has its cons. That's obvious, like everywhere. So the problem, and I was also responsible in the first days to create a document about the risks. What kind of risks we have after we fork this. And I created like 5 pages, like point by point, bullet by bullet. So when the guys saw it, they said, we are happy that we already forked it, because with that, we are not sure if this is a smart move. Anyway, there can be changes in the binary itself, right? And it happens, really. This is the new version of Terraform. So OpenTofu is following it. Of course, we have to write our own code. Or they have to write their own code, right? And maybe you heard that it was like, I don't know, 1.5 years ago, that Hashi claimed that OpenTofu group copied illegally the code from Terraform to OpenTofu. What was partially true. Yes, we copied it, but it was not illegal. Why? Because the feature they announced at that time, and we had the same code, was created like 2 years before, and it was hidden there. So we just unhidden it. So it was not like copy after the license change. So the case even didn't go to the courts and so on. The short explanation from OpenTofu team was enough, right? So it was like a health check.
Didn't the license change from certain version up?
Yes, it was from 1.5.7.
That was the old
Exactly. They couldn't change versions back. And they could change the license because normally when you contribute to the code, you agree to some rules there. And there you had something what was something like this. In future, we can change the license and you have nothing to say about that, right? Many open source tools have something like that. So if you contribute and you want to ensure that your code will be always really open, check this first. Okay. Of course, after the things started to go faster and faster, OpenTofu kind of followed. Of course, they implemented new features and so on, like for example, the state encryption. But also you can still relatively easy, in relatively easy way, migrate from Terraform to OpenTofu. But you have to be strict to the versions. For example, from version of Terraform 1.8, you can migrate like generally safely to 1.9. You can't do, for example, for 1.10 to 1.10. So you have to remember about that. And will there be more and more differences? Yes, of course. In some point, they will be not compatible anymore. So this is it. We have a couple of differences between them, and just we can say that as everyone uses AI, OpenTofu also has its own MCP server. And now let's do very quick demo to show you how easily you can migrate from Terraform to OpenTofu. So we have like starting state. I deployed the Terraform infrastructure into Upcloud. Then we will see what is there, and then we will migrate. Okay? So let me just try this.
Should I hold the mic?
I can manage. So here we are with the simple code. We have a couple of things. I have this documentation, let's say, to to look smart and that I know what I'm doing. We have Kubernetes cluster. We have a database deployed, which is like separate from this cluster. We have also some kind of bucket deployed, and that's it. So what I have there, just let me move. Come on, not here. Here. Let me move just here. What I will do is show you what I have deployed there. Let me copy this part. Because having just the cluster is not enough. So let me just copy it. I hope I did it. And put this into the... Maybe not. All right, I'll go to my laptop, okay? I'm sorry. It will be faster. Okay. Now I'm going to my...
Oh, it doesn't go.
It didn't go through the command.
There was some junk.
So here I have Wolfenstein, right? So I'm old enough to be familiar with this game. How many of you played Wolfenstein? Good. Right, so this is this simple thing. What I have here is Terraform, really. So let's see. I think it was JSON, JQ. Yeah. So what I have here is my description of what I've created, and you can see I have something like Terraform version. I have some information there, and also I'm using registry Terraform.io. Please notice that. What kind of providers I'm using? Terraform providers. As you can see, all providers are from Terraform, right? From Ashish. Okay, now I can go there. This is interesting. Okay, so I have these providers. What I need to do in order to run Tofu there? First, I have to install Tofu. I already did it. So then I have to do very complicated command. I hope you can see it because it's kind of low. Let me do this. Bear with me. This is very complicated command. Okay, now my tofu is initialized. When I do the command tofu providers, you can see not many things really changed. I mean, a lot of change we see on the top, but what is needed by the state is still the Terraform registry, right? Because I didn't do anything with my code. So if I do tofu plan, right now I don't have any changes, so I can't do really the thing here. So let's change something, whatever thing we can do. For quick thing, for example, we have here the label. You can treat labels as kind of tags, like in other cloud providers. So let's use OpenTofu. Will it save? No. Oh, come on. How to save this? Ah, yes. I'm smart. All right, so now if I do tofu plan, you can see something is going on. So we don't have a lot of time left, so I just do the tofu apply. Yes. Yes. And now this change will be applied, right? So as you saw, I didn't change generally nothing in my code, right, to run tofu. But what I've done first, I was sure that I have proper versions of it, right? So proper version of OpenTofu and proper version of Terraform. How you can manage those versions with tfenv and tofuenv, really. So it is applying, as you can see. So we can come back to this beautiful presentation because it is almost the end. So this is the last slide. Really. No, I'm lying. Almost the last. So if you want to try with the code I showed you before and will be here in a second, go to signup.upcloud.com, sign up, use it, have fun. You will have. And this is the code. Thank you very much. I'm here for longer, so if you have any questions or want to discuss something, so that's fine. We can discuss.
All right, and we are a bit running late, so I would immediately jump to the next presentation. Ashish. And then we can have food and drinks and a little bit of break. One thing what I forgot to mention in the intro, that we are uploading the slides to the Meetup page, so you will be able to get the information, including the
Yeah, I sent it to yeah. And the code will be available as well. So.
Cool. It's here.
Luck. Second, I think thank you, Upcloud, for hosting us. Just let us be there for some more time before kicking us, and then we'll see. Thank you. Now, we go ahead. Third thing, I think Pawel stole my question. I wanted to ask, like, how many of you are using AI, but he stole it.
Sorry.
So I think, yeah. So how many of you are familiar with vibe coding? Have you heard about vibe coding? Yeah? All right. Good. Then we are there. I think you said a nice premise about AI everywhere. So I wanted to talk about like how AI and security in AI is kind of evolving, how fast this space is moving. And it's not only about the CNCF projects, what we can use, but what can we do, or how this space is evolving so fast, what can we do to secure it, right? Allow me to introduce myself. I am currently working as a security engineering manager for Ikea. But my previous background, I have been working for Zalando, Unity, and Skype in my previous experiences. So, yeah, whatever I say, just take with a, pint of salt, right? So yeah, the question which I started asking, how many of you are familiar with the vibe coding, or how many of you use. Here, these numbers, some of you are already there, right? 1.8 million GitHub Copilot users, Microsoft and I think Google as well. They have accepted that 30 to 40% code in production nowadays are going through these AI-assisted coding, toolings, right? The development cycle has improved a lot, right? Microsoft has accepted in their environment 57% of increase in AI-related security incidents is happening, right? Whether this is phishing emails or trying several other ways to trying to get into the environment. Just this week, I think IBM's data breach report, or IBM's data breach costing report came out, and it says that I think 13% of its respondents says that 60% or 63% to be precise, if I remember correctly, the respondent has said that AI security incident has costed them the data breach or service disruption. Those kind of incident has happened already. This is happening in the production environment as we go. Now, the drama part, right? Who here knows about the T-app incident? Anybody heard? Yeah. See, I need your drama, all right? Let me talk about this one. So, allegedly, somebody, built an app called T-app, pretty famous in US dating scene especially. This dating app was for women to actually rate men's, and it was pretty popular. This went pretty kind of crazy. With people started using it. One guy started looking into like how the infrastructure, how the database looks like, and he found out that the people who were using, or the women who were using it mainly, the data for them is basically unsecured. It's there in the database of unsecured server, and it was pretty much downloadable. So he casually started doing this. 72,000 women, as we know as of now, data has been publicly leaked, right? Interestingly, and I don't know why, that data included the geolocations, the images and whatnot. So some of these interesting details were that this data, these photos, these profiles were coming up from really, really secure locations in the US, like military bases or the senators' houses or some interesting places. That's pretty much a great drama to beat, Farah. You cannot beat that. Then the second incident, and these incidents I'm talking about, these incidents just to show you that the consequences of what could go wrong. The second one, if this could happen with Amazon, imagine where do we stand, right? Amazon queue incident, if you go back into the history and check how one developer somewhere kind of sneakingly added some code into this tool, which basically started which had the wiping commands in it, right? The tool which is being used by developers, trusting that these are kind of Amazon toolings. That could happen, or that happened actually, and this was a pretty interesting story. There are several other incidents happening. There was one kind of database wiped out. There was several incidents happening as we go, as we are evolving. So these are just not the incidents which is happening isolated. This is happening every day in all the environment. If you use it, in some ways, it's reaching out there. Now, when I say it's already there, it's reaching, these are the stats to prove. If you look at this, this Grey Swan AI paper which they released, I think this week or last week, if I remember correctly, they have done some security challenges, some real red teaming activities, and they found out that the 1.8 million prompt injection attacks submitted by 2,000 participants, which they were kind of playing with, and 100% of policy violation rates across all the LLM models, be it OpenAI, Cloud, ABC of those LLMs models. They all had, people could actually breach, people could actually compromise all of these LLMs, and they could get them to do what they were, trying to do, right? The vulnerabilities identified, if you see, system prompt override, Fox reasoning, session rate, indirect prompt injection. This was all practical. This was happening practically in this red teaming. This report is very interesting if you want to kind of read through it. Great report into what is happening in AI security. Now, AI and security, not so much together as of yet. Now, when we are talking about AI infrastructure, you touched up really, sweetly about MCP and everybody is building their own MCP servers. Docker released these horror stories just, I think, very recently, just a couple of days back, and in that they say that there were command injection issues or vulnerabilities in 43% of public MCP servers. And these MCP servers are tools, resources. People have started using these MCP servers in the production environments, while we don't know what is happening behind the scenes. Look at these numbers. 33% of these MCP servers or these infrastructure elements allow unrestricted network access, enabling data exfiltration. And you wouldn't even know if this was happening because I believe that there are only some people who have started building those monitoring capabilities to know that if it is happening in their environment. Last part, 558,846 plus downloads of vulnerable MCP remote packages. Here we are talking about MCP servers as a very kind of genesis, and this is already starting to happen. Great data points and great statics from MCP or Docker actually, pretty interesting. And Docker is actually doing some great work in terms of creating these security or providing the AI infrastructure security features in their side. So Docker have actually released some product, and I think they are going there as of now in Black Hat and other conferences talking about those stories and the products which they're building for AI security. So keep an eye on them. Now, this risk as a whole for people like us working in security, this risk practically came up 0 to 24 months in last 2 years practically, from non-existing to existential threat, right? If you see, we used to be worried about APIs, third-party libraries, secrets, web apps, how do we secure them? Let's do threat modeling, let's take our time to secure them, let's do the manual code reviews. Sure, we are the security, we know what we are doing, right? I don't have the same confidence in saying so. Again, LLMs, MCP servers, AI agents, these are evolving so fast that, and I'll make sense in a moment when I go further, how fast it is moving, right? When I say that we started to kind of build on the tooling, on understanding on LLMs, how do we secure them, how do we secure MCP servers, AI agents. We started creating processes and all, and then something like cloud code comes into the picture and it starts changing the game as of today, right? We'll come to that, but things are changing that fast. Processes or how things are changing. This is how SDLC used to look like, right? The tech stack, or currently, if you see the AI powered tech stack, right? Backstage or in right now, if you have one agent, Cloud Code or GitHub Spark or ABC of those tools, you just start giving these verbal commands and it starts building things for you, right? It starts building, deploying things for you. If you take Replit agent, it goes and start deploying things for you without you even knowing that where in the background it is deploying things. So this is how it's evolving. The SDLC is evolving, right? And then comes the security. How do we do security for the SDLC which is changing this fast, right? Now we have to think about this is again from a company called Pillar Technologies. They have released this diagram about secure AI life cycle, something like that, if I remember correctly. Yes, AI development life cycle. Now, if you see, we were thinking about building the security requirements and the checks in these SDLC phases. Now you have to also think about these and build the toolings and supported processes, right? And I'm sure not many of the teams out there have already started thinking in this direction, like how do we create an AI native SDLC and provide toolings for that, provide processes for that just yet. The security velocity, it has completely changed, the development, how fast it is evolving, how fast it is going, it has completely changed. We used to take, I was just kidding that, we used to take our own sweet time to do the code reviews, threat modeling processes, take it slowly, we'll do the architecture review and then we'll kind of, give you the go ahead and then we'll do things. It's changing. This 25 to 30% of development lifecycle time, it is changing. People are using PR reviews like CodeRabbit and other tools to do the faster, code reviews. That has some capability to do the security code reviews themselves, right? When they come to us, it's more or less done deal, right? And then we go ahead, all right, let us take as a whole. Let's do a security architecture, let's do the quick thinking. And then, go ahead. This is how it is changing. Security is, if you know what tools to use, if you know when those tools to use, you can do things right? But this space is evolving so fast that I believe that even after saying that, yes, I'm doing everything right, you cannot be sure that if, we have built a secure product or not, right?
It might be secure today, but not tomorrow.
Well, by the evening itself.
No, I mean, without any change.
Yeah, no. I understand, thank you. So yeah, you're very right. It's, and I will give you an example. I was talking about Cloud Code, and I'll go in detail and talk about that. They have released a tool today itself. It's called Cloud Code Security Review. So as a part of tooling from Cloud Code, which does the security review for you, goes one step ahead, fixes those security reviews for you. You have those capabilities to find those. I have the data, the screenshots to show you. But it does find things for you, it fixes things for you, and then goes ahead. So I don't know if I will have a job. But anyway, coming back to this, when we are talking about the AI native developments, these are the attack vectors which are opening up. Code injection, model poisoning, prompt injection, supply chain attacks, data poisoning, adversarial attacks. These were, well, some of these are not new. These were previously existing in the previous SDLC as well. But now, this changing has bigger consequences. Like if somebody has a prompt injection in your AI-enabled app, and somebody just tweakly, and I'm exaggerating it, but if somebody tweaks just one prompt and says that, forward all the mail from, whoever receives this mail to my this address, or, connect back to this production database servers and send me all the data from this because I want to do this analysis. So very exaggerated thing, but it might be possible because of, the possibilities which AI has nowadays. Some of the people, if I remember correctly, there is a company called Repello AI. They did something similar with Zapier, where they did a kind of command injection, and they started expelling out some of these things. This was I think a blog from them as well. Since we are in a CNCF talk, there are these tools which we can use in these SDLC stages, right? There are some other tools which we can use. Tools are important, but what is more important is refining those tools to detect these attack vectors in your development life cycle, in your in your process of building softwares in your deployment, in your release cycles, right? You need to be able to detect the vulnerable patterns. You need to be, put detection and prevention mechanism for supply chain security. You were using Trivi already, or you were using some other tools already, but now you need to think in another ways, right? Yes, there are vulnerabilities in the packages and all, but now you need to think about vulnerabilities in these attack vectors, right? So yes, these, what you see here on the right side, these are the risk areas which we are trying to kind of mitigate in the SDLC phases, and I will upload these slides anyway, so you can have these in detail. But these tools are the CNCF tools. You can use any of those tools. We started using SandGraph for SAST, OpenSF SSF scorecard, which is not CNCF projects. These two we really love, kind of to build the visibility, to build the kind of metric measurement and so on. So we love these two tools. Now, if you put the right kind of toolings and the practices in the SDLC, this is where we need to be in terms of, we need to protect our CI/CD pipelines. We need to build some solid toolings to detect where the security issues happens. Possibly auto fix them. I don't know how to auto fix them just yet. There are some toolings, some capabilities building which can actually auto fix those things. Find and then auto fix. Cloud Code security review is one of those examples which were just released today. Proactive security. I have this basically this conflicting idea of, oh, there is someone down there. Yeah, okay. Right. So the proactive security, in my opinion, is very is a word which I kind of like to say. There is nothing proactive anymore we want to do, but then, as you rightly said, things are changing so fast that I want to do the security right now, but I know that this will change tomorrow, right? So I have to always go in a bit more reactive way. How my software stack is changing, I have to put the right controls in there in those appropriate ways to do this, right? I think the last part here, real-time monitoring, is very important. Falco currently provides you those capabilities where you can do these AI-specific rule sets to, I have actually 2 examples in there. You can create those API calls, suspicious API calls detection. You can create something like, the data exfil detections, with the Falco rules. So that one I would highly recommend to have in your toolings, in your CI/CD pipelines. Absolutely, in a runtime environment to detect faster, right? This is what I was earlier talking about. I think I've been very fast, but this is something which I was talking about. This is hot off the press, today released. Cloud Code. How have you used Cloud Code? Anyone? Right. In the Reddit community, these are addicted people. Cloud Code is so good that it basically makes you addictive of how good this is in terms of architecture, in terms of building things, right? How would it understands architecture, right? And then if you see this, the security review, when they started finding the vulnerabilities, look at these vulnerabilities, right? Path traversal, XSS. These are all the things which, as a security teams, we used to take time. We used to run toolings and find out, and then create a strategy for fixing. It found out. You give one more command, fix it. It goes back into your environment and fixes those things, and then comes back, right? So it is going to change the direction how people are building with agents, and how previously, if you see the little bit, historic drama about vibe coding, people were building things. Non-engineers, non-developer were building things. They were mostly not taking care of security, and that's why people were like, you're not building secure product, you're not building quality. Now it's this easy for them as well, right? That's a very good thing in my opinion, for people to have these kind of tools for doing the security review, for fixing automatically these kind of low hanging or these kind of basic security issues out there, right? AI is good when it is doing the positive thing, but can be very pro-adversary. If I know how to use it maliciously, uh, things are not good, right? And I think AI is being used right now more efficiently by adversaries than the defenders. The good thing is this will change, right? So with that, I will upload these slides. I have some examples of how and what kind of tooling configurations we can put in there. So I'll update these slides up there, but I think security game is changing. AI game is changing. Yeah, keep an eye. Don't get demotivated. We all will see each other, right? Thank you. This is my time.
Thank you very much. We will put the slides to the Meetup page. And now let's have a couple of minutes break and have some drinks and food. Enjoy. Right. Let's continue with the edge and Jussi.
All right, thanks. All right, hope everyone got enough beer already, so it'll be much more fun that way, right?
No drama.
No drama.
Yeah, let's see. I had some drama already setting up my demo, so, let's see. All right, Kubernetes and the edge. What I'm going to talk about today is well, we have to first define what is the edge, or what I mean by edge in this talk. Why Kubernetes, lightweight clusters, K0s, and then let's go a bit also beyond the edge, beyond the computer nodes, whatever they are, and what's behind them in the edge. I'm going to do a very, very quick introduction to a kind of architectural pattern using K0's Kube distro and another CNCF project called Akri. Let's see if we have time for any Q&A, but I'll be hanging around the whole evening, so. Yes. Live demo. I don't know if you see, I'll move the stuff around a bit maybe later, but I have actually Raspberry Pi running with a webcam, running some models and stuff, and let's see how it works. If you ever seen my talks, I usually do live demos, and my kind of motto is that if it doesn't work, let's make it fail in a spectacular way, so at least we get some laughs out of it, so that way you'll remember me.
Is there going to be fire involved?
No guarantees to either direction. All right. So, I'm Jussi. I'm senior principal engineer at Mirantis in our open source program office organization. I've been working with cloud native stuff even before it was actually called cloud native. So, yeah, tell me you're old without telling me you're old. Currently, I spend most of my working time leading the CNCF Sandbox K0 project and all the stuff around it. All right, so edge is one of those kind of terms which is kind of difficult. What I mean by that is that if you talk to 10 different people about edge, you might get very different, opinions, but, well, let's call them opinions now. Opinions, what is edge, Just as an example, I had a discussion a while ago with an organization where they basically said that okay, we want to have a Kubernetes at our edge. Like, okay, what is edge for you? For them, it was 3 racks of servers running VMware. I was like, well, okay, yeah, let's call it edge. I wouldn't really personally call that edge, but
So what's the core, did you ask?
Sorry?
So if that was their edge, what was the actual central computing stuff?
AWS. So, but yeah. For some others, edge might be like a super tiny computers running automation in a factory which is building cars or something like that. So it's like, yeah, whatever edge is. In the context of this talk, what I mean by edge and far edge is basically computing that happens way on the edge of any capable network, whether it's 3G connections, whether it's satellite connections, those kind of things.
LoRa.
Could be LoRa, absolutely. And in more kind of compute-oriented manner, it's very resource-constrained computing. Think about Raspberry Pi-sized devices and a lot smaller even. I mean, Raspberry Pis, they have like 8 gigs of RAM and all that stuff, so it's like super, super fancy actually, if you think about it. What it also means from Kubernetes point of view is probably you'll end up having more clusters which are smaller in nature. So instead of having 1,000 node clusters, you might have few hundred few node clusters. Because of resources, because of networking. I mean, if you have like one node in China and one node in Finland connected through LoRa or 3G connections, you might find it quite difficult to put them actually in the same cluster because of networking reasons. Well, I already mentioned Kubernetes, but why do we actually want or need Kubernetes at all at Edge? I mean, there's of course an obvious answer. We're at the CNCF Meetup. We love Kubernetes, so we want to put it in any single place we can. I'd put it in my kitchen toaster if I'd be able to, if it would have a CPU. But
You don't have it there yet?
it doesn't. My toaster doesn't have a CPU. Fortunately, I think. Anyway, if you think about Edge and you want to run applications, whatever they are, on Edge, you would need to have some sort of orchestration for those applications, right? You would need to define some sort of packaging. How do you deploy your application on a variety of different computing platforms, whether it's a Raspberry Pi running your typical ARM64 architecture, whether it's a factory automation PLC controller running some super slow ARMv7 CPU and maybe a few hundred megs, not gigs, megs of RAM. You'd probably want to have automation, scalability, resilience, all that stuff. And you would probably want to have a declarative state, how you manage things. Well, it's quite obvious. We already have all this stuff in Kubernetes. Very, very quick intro. One slide intro to K0s. So, as I mentioned, K0s is a CNCF sandbox project, a kube distro, where the aim has been from day one to have as minimal footprint as possible. I mean, it's still Kubernetes, so it's not like super small. And it's Golang, so it's not like super small. And it runs all the Kubernetes components, so it's not super small. But as minimal as possible, given the constraints that we get that, you know, we want to have Kubernetes, right? It's built as a single static binary, which means that we have virtually zero dependencies. We do have dependencies to some very, very basic Linux tools like du and mount and those sort of things, but you can't really run Linux without those anyway. So, one of the unique architectural patterns that we have in K0s is this what we call worker controller separation. What I mean by that is that when you, by default, when you run a K0's controller node, you don't get kubelet, you don't get containerd, it's a pure controller node. Which means you cannot run workloads. I can't deploy pods on a controller node because there's no kubelet, right? Sounds kind of weird at first, probably, right? Why would you do that? Well, it actually fits the edge really, really well. Because what we can do with that now is we can actually centralize the control planes. What I mean by that is I can centralize my control plane in a way that it's running maybe on a public cloud, maybe on your data center, where you actually have resources to run all the API servers and etcd and all the things that hog like half of your data center computing power, right? Because we don't have that luxury on edge. If I take an actual example that we work with, the factory automation PLCs, they are actually running ARM v7 CPUs and 500 megs of RAM. There is no possibility to run control plane there. I mean, just from the resources point of view. If we would be able to figure out the networking part even, there's just not enough CPU and memory. So with my edge and edge nodes acting as pure worker nodes, they are quite slim. They run kubelet and containerd, and the rest resources are for your workloads, right? Which also means that now I can very easily control my whole edge clusters. Because my control plane is running on, say, public cloud, the control plane is pretty much always available. The edge node, it might be disconnected for a while, yeah, but next time it syncs up again with the API server, kubelet pulls the new data, that new state of things, and it tries to fulfill the state, right? Remember, Kubernetes is an eventually consistent system. You tell it that I want things to be in this state, and next time kubelet comes up, it'll resync. One other project that we donated to CNCF in April, I think. Yeah, it's called Cosmotron, which is basically a tool, or not a tool, it's a cluster API provider that allows you to run control planes in what we call the pattern hosted control planes, meaning that the control planes are actually running in some other Kubernetes cluster. So think about the use case on edge where you might have like hundreds or even thousands of clusters. You can actually run control plane on each of those clusters as a pod or set of pods in some management cluster, whatever you want to call it. I usually call it the mothership cluster. And yes, I'm really into sci-fi stuff. All right. So basically, disconnecting the control plane from the worker plane allows me to push my nodes to the edge. Let's look at a bit beyond the edge. I mean, your application is doing something at the edge, right? It might be connected to the world of IoT or IoT-like environments. Akri is a very, very cool another CNCF project, like I mentioned. Basically, what Akri gives you is kind of a discovery framework to discover your IoT and IoT-like devices. They could be USB or IP cameras or whatever. What's cool about that is that when it actually detects something available, it exposes that as a Kubernetes resource. Which means I can actually start to schedule my workloads based on available resources outside of the compute itself. So I can basically say in my deployment that, okay, this deployment or these pods require a camera instead of requiring a CPU or memory. I can actually say that it requires a UDEV camera. I don't have to figure out that okay, on which node a camera is actually available, because that's what Kubernetes does anyway for CPU and memory. So it's leveraging the exact same framework. Akri comes with, let me rephrase. You start using Akri, well, of course, you help install yada 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 first, but you feed it basically with a configuration. In the configuration, you basically say that, okay, I'm using this protocol as my discovery handler. In my example, it's called UDEV. And then some other specification, whatever you want to customize and define in Akri. What it does, it basically deploys an agent and a discovery handler on every single node as a daemon set, quite typical pattern. And then the discovery handler figures out that how I'm going to discover things. In my demo, it's a simple UDEV probe on the kernel, and that's about it. It could be trying to figure out some IoT devices based on some IoT protocols like OPC, whatever it was called, OPC something. Or it might discover IP cameras using the ONVIF protocols and whatnot. Or you can write your own protocol handler, of course, it's open source. So basically, for the demo and as a general pattern, we can really do cool stuff on the edge using this kind of an architecture where we separate the control plane from the worker plane, and especially for the far edge like deployments. And if we are clever with the networking, use things like WireGuard or other cool things. We could actually deploy some nodes also on some near edge data centers where you actually have more computing power. If we think about the world of AI or AI nowadays, you could maybe run some GPUs in a near edge data center. The far edge would be actually dummy stuff, more like fetching data and then feeding it to the AI models on near edge, or public cloud or whatever. Or if you get your hands on some Jetson Nano stuff from NVIDIA, you could actually run very, very cool AI stuff on the far edge too. And if someone knows how to get one of those boards, tell me. I've been trying to get one for months and months, and it's always sold out everywhere. So, because those are super cool. So, in the demo, what I have is I have basically a cluster in public cloud, which I'm using as a mothership cluster. I have a cluster API there. I have our Cosmotron running there, which is managing a single control plane for me. And then on my far edge site, I have a Raspberry Pi running. I have Akri deployed. Akri is doing UDEV discovery, discovering the webcam from USB. And then I've configured Akri to deploy a thing called what they call a broker. And in this case, the broker is actually a super cool piece of the puzzle, because what I want to do is in my application is, of course, access the frames from the webcam, right? I have no idea how to do that. Well, I can of course wipe code it together, but in practice I have no idea how to grab a frame from a webcam, right? But actually with the broker, I don't need to, because the broker actually exposes the webcam via gRPC socket. So now my application actually doesn't have to understand anything about webcams. I just talk gRPC to some other pod somewhere, and I get frames, which is another super cool piece of Akri architecture. All right. Fingers crossed, everyone. I'm gonna be super loud now, so I don't need this mic, because I need both hands to type. All right. So, yay, everything is still running. All right, so like mentioned, we have the Akri agent running. There's a controller deployment, of course, for it too. There's the discovery daemon set, and then there is a pod called udev something pod. So this is basically the broker for me, because it's actually discovered a udev device with this ID. So I'll hopefully be able to show. Yeah, like I mentioned, when Akri discovers devices, it'll actually expose them as resources. In this case, the resource is called an instance. And, well, you see the ID, and it actually marks that it's found on this node. Well, it's the only node in my cluster. Well, cluster, but you get the point. And if we look at the node, we'll see that I have capacity unallocatable stuff. And you see that I have this udev something something. And there's actually another udev lying around still. It's actually sort of wonky that if you unplug it and plug it to a different USB port, the device ID changes. Like, okay, but it's just how it works. And don't ask any more details, I have no idea. And yeah, based on these, I can actually tell the scheduler that where I want my pods to land, which is super cool. And then of course I need to have some demo application. I'm gonna scale my demo up. It's up and running. Oh. I'll move this, yes. I know I'm not recording anything, so it's just live frames. Oh my god, warriors. So it's basically just running a object detection model, and yeah, that's the application. It's like super dummy, but I think the main point of having an application like this running on edge, as you know, on Raspberry Pi, I don't have GPUs, so I can't run any like real AI or anything. But even with plain CPUs, you saw, or you see, I'm getting like 3 to 5 frames per second through object detection. So it's actually pretty decent, I'd say, in a way. And if you think about the typical architectural pattern that we've seen is that, you know, the far edge is doing the more like pre-processing of the data. You could actually do pretty fancy pre-processing already with these sort of resources. And of course, then if we scale down to the factory PLC case, then we won't probably be able to run anything like this even, but you know, that stage, you are very resource constrained always, and that's just the life on edge.
Which Raspberry Pi is that?
It's the Pi 5.
Okay.
like I mentioned, this demo would be a lot cooler with the Jetson Nano stuff because they actually have decently powerful GPUs. So, but they do hold a lot more power than my Raspberry Pi because I'm actually powering my Pi via a battery bank. So
I use Raspberry Pi Pico W2 for web streaming.
yep. You could probably do
It's streaming quite
something
nicely.
similar to this. Yeah. I wanna. I'll use the mic. I wanted to highlight one use case, which is actually using this exact same architectural pattern, and it's actually using Raspberry Pis. So a colleague of mine has been actually working on this. It's a non-profit organization in Vietnam, I think. Yeah, Vietnam. Where they want to basically monitor the health of coral reefs. And what they basically need to do is collect data, collect the quality of water and analyze the water and, you know, all that stuff. So what they actually developed was this sort of a underwater buoy. It's connected to the network via 3G antennas and 3G SIMs, powered by solar, of course. They have battery banks running Raspberry Pi 5 or 4, well, Raspberry Pi anyway, doing all the data processing. And then they are connected to a central or centralized control plane, because you don't want to run control plane underwater like that, right? Well, you probably could actually with Raspberry Pis, but then how do you connect it? How do you ensure the state of things and all that stuff? So that would be difficult. The link, the QR code takes you to a better write-up on the project. But I think as an Kubernetes edge example use case, I don't think you can do much cooler than that. They are dropping these like, I think it's like 300 to 500 meters offshore, and it's so cool. I volunteered to go debug stuff there if something goes sideways, but no one's called me yet. I don't want to do remote in this case. All right, so I mean, there's a lot of other use cases. I mentioned like industrial automation several times already. There's a lot of use case popping up in retail, and now especially with the AI stuff being so big. Kubernetes, as we saw, can work on the far edge, especially with control plane, worker plane separation. And then with K0's Kubernetes and Akri, you can do actually a lot of cool things. And it's a simple-ish architecture for these kind of use cases. I mean, it's still Kubernetes, so whether it's simple can be debated over a beer. Right. Thanks. Spot on.
Right, and the last talk is from Anton and about LLMs.
Also before Anton will prepare himself, just remember with this thing, nice thing, you have this code and 100 credits for you to use Upcloud, to use it, build something, stay with us for longer.
Is that connected to this also?
Is the keyboard connected to the?
Yeah, you can try to connect it, but I don't know the combination of this to connect it. So it is Bluetooth, so you can find it.
Ah, it's Bluetooth.
Yeah.
Okay, just checking.
This one is don't do this for frequency. Let's switch over the mics.
Stage here, even though it's a last presentation. How do we like to imagine things? Imagine if you would have ChatGPT-like interface for all business users with enterprise data. And you would imagine something else also. Imagine independent AI agent executing tasks without human intervention. Imagine teams of agents replacing humans, just kidding, boosting productivity and generating shareholder value. That's the main thing. And imagine all this with full control on European infrastructure. My name is Anton. I started my IT career 27 years ago for Sun Microsystems by that company, even though I think that was the best company. We wouldn't have any kind of cloud infrastructure without that company. I'm from Cloud2, director of cloud, so you can assume that even though with technical background, I've forgot lots of things during the past 27 years. Cloud2 in a nutshell, founded 2017 about 130 passionate cloud professionals in Finland and in Denmark, and lots of satisfied customers. We work with AWS, Azure, Google, and of course with Upcloud. Managed services, resell, whatever, consulting, professional services. Today, we are talking about our newest child, AI Control Room. AI Control Room is a tool, product, which you can install on AWS, Azure, Google, and on top of Kubernetes in Upcloud. You can replace your co-pilot or whatnot agents with ones provided by AI Control Room. You can build agent teams, automated tasks, event-driven automation with AI in your own environment with your own data. This is just an example of what you can do with AI Control Room. I have lots of slides, but I decided that I will show something also. It's more interesting. Something behind the scenes. Today I will show a demo running on Upcloud infrastructure, utilizing new GPU instances and managed Kubernetes services. But AI Control Room provides MCP server, marketplaces, application, supports Akri and client chain and whatnot. LLMs, you can utilize LLMs from Olama, and as I said, you can connect it with Google Gemini, AWS Bedrock, Azure OpenAI services. And as someone might saw a TV article about our joint venture with Upcloud, how to AI solution combined with Upcloud infrastructure. So what we provide is our AI Control Room and Upcloud's managed Kubernetes, LLM service layer, utilizing Upcloud's new GPU servers. And of course, on top of that, if you want, we can monitor and manage those services for you, help you build agents and agent teams and develop your AI capabilities. And some more information about those subjects. And what we get is full control, EU-hosted AI platform, total freedom for you to choose your models and platform, dedicated GPUs, designed for EU needs, so no compliance issues, no vendor locking. Let's go for the demo. So here I have the end user view, the chat GPT like interface for end users, where we have different kind of LLMs to utilize. You have we test different models with the same question. Does anyone have a question we could use?
What are the things you pulled out?
what was the
Yeah, I can see them.
So here are these are the agents with different type of LLMs. So you have
We can't see through you.
here. Okay. So here are all the models that we currently have. So Mistral, Pi, when tools, DeepSeek, actually DeepSeek doesn't work. We had some issues with that. Yesterday's announcement of GPT OSS is also available here. And through Azure we have also GPT-4. But if you have some question, we test what kind of answers it gives to you for trying different models. Do you have any kind of questions?
Explain quantum physics.
Okay. Anything else?
It wasn't trained for that.
I don't know. Let's see. If I can write. Then copy and paste it so that you write it again. And let's try with Llama.
If you control plus, or if it's Apple, in my case it's the option plus.
Okay. No, obviously. Okay, fair enough. Let's try Mistral. Yeah. Okay. Then let's try Pi. Okay. Sounds good. Let's try when. As you can see, the GPU instances from Upcloud are quite fast. And with when it's quite fast, it tells you what it thinks, and then tries to give you some kind of an answer. Then let's try Azure. No, this GPT OSS. So this was yesterday announced GPT OSS version. As you can see, it has icons, lots of stuff. Nicely presented.
well.
Let me check. So here we have a control panel for AI control, and for example, here you can see how it connects to Gemini. So this is how it's configured, and through those providers you can get different models. So we have normal connection, and we have installed. You can see here these are all through all. We have other from Azure and Google. I tried to build and show you the agent HR Sirpa, but there was some kind of bug in indexing the Confluence database, so I wasn't able to do that. But let me check. I could show you some kind of demo in our production environment. Here we have HR agent again, and we can ask questions from him. So it gets all the information from our Confluence page, which is linked. Let's see if the application works. It gives you the place where you got the information. The nice part here is that even though this information is in Finnish, you can ask in English and get the English answer, so you don't need to kind of translate all of your Confluence pages into English or whatever language. You can have only one version and still get the answer in the language what you prefer. Was I fast? Maybe. But that was it. Thank you. Let me go back into the slide. I asked our developers to collect some information about that. So basically, as far as I know, we are utilizing Akri.
So yeah,